Hi, in this video, we'll learn the basics to a programmable benchtop power supply, a fundamental cornerstone to electronic test equipment. Familiarity with Ohm's law will be very helpful when learning about DC power supplies. Ohm's law is voltage equals current times resistance, or V equals I times R. Power, measured in watts, is calculated by multiplying current and voltage. That's P equals V times I. A DC power supply provides DC voltage to power electronics. The power supply has an adjustable output voltage, making it a very versatile power source for just about every electronics project. It is particularly useful when your project incorporates motors, lots of LEDs, or any high current demands. A reliable and robust power source is the heart of any electronics endeavor. TechSpark typically has digital power supplies with 3 channels. 3 channels as opposed to 1 means that this power supply can function as 3 independent DC power sources. Each channel is a DC power source that can be adjusted and set to a specific voltage and current. To turn on the power supply, press the power switch on the front. A good practice to always follow, your circuit should be disconnected from the power supply when powering on any power supply. A previous user can set power on configurations that automatically energize the outputs, thus could damage your circuit. This Rigol power supply has 3 channels, identified as yellow, blue, and pink. The output terminals are also color-coded to identify which channel they belong to. You can see each pair of output terminals indicated by the respective color, yellow, blue, and pink. Each pair of terminals is marked with red for positive voltage and black for negative voltage or DC ground. This green terminal is the chassis ground. This terminal is connected to the ground prong of the AC power cord. This instrument is grounded to earth when using a 3-prong IEC appliance cord. Each output channel can be turned on or off. On means the voltage and current set on screen is available at the banana jacks. The output status, meaning if the channel is on or off, is indicated by the backlit on-off toggle button. Lab-type power supplies use banana jack connectors. You can connect to the banana jacks by means of a plug receptacle style test lead. Common leads are ones with alligator clips on one end. Just note there are many types of test leads other than alligator clips. You can also connect bare wires to the output terminals. To do this, rotate the outer nut of the output terminal counterclockwise and connect the wire lead through the hole of the output terminal. Then rotate the outer nut of the output terminal clockwise. This will clamp down on the wire. This connection method can eliminate the error caused by the resistance of the output terminal and some test leads. Channels 1 and 2 have an overall maximum output voltage of 30 volts and a maximum current draw of 3 amps. This equates to a max power output of 90 watts per channel. That's 30 volts times 3 amps. Channel 3, pink, has a max voltage output of 5 volts and 3 amps. That's a max output power of 15 watts. A 5-volt output is a very common voltage for digital electronics. On multi-channel power supplies, it's common to have a dedicated channel for 5 volts. The combined maximum power output for this power supply, that's all 3 channels energized and outputting at their limits, is 195 watts. This meaning there's enough power available in this power supply to be dangerous if you're not careful. To set a voltage for an output channel, press the color or number of the output channel you want to control. To adjust the voltage, press the voltage menu key. Move the cursor to the significant digit you want to adjust. Use the encoder wheel to change the value up or down. You can also type in the voltage using the number pad surrounding the encoder wheel. At this time, you can connect your load to the output leads. Turn the output on by pressing the on-off button for the respective channel. When the output is on, this button will illuminate. You can adjust the voltage while your circuit is connected and the output is enabled. Just be careful. An incorrect button press or a slip of the hand can send too much power to the circuit by doing this method. To turn the output off, press the on-off button for the respective channel to turn it off. The benefits of a lab-quality power supply is to see how much current is being drawn by your circuit with the on-screen display. If you plan to make your project battery-powered, this number will help determine the capacity of your battery. Another useful feature is setting current or voltage limits. As you build your circuit, you might have to adjust voltage and currents. You might have a known voltage or current limit you want to avoid. Exceeding these limits would be fault conditions. The power supply can serve as a safety spotter. For example, if your circuit starts to draw more current than a set limit determined by you, the power supply will turn the output off to protect your circuit. Setting limits controlled by the power supply is a great protection feature. It's up to you to decide if you want to use over voltage protection or over current protection. These meaning exceeding a voltage limit and then turning off, or exceeding a current limit and then turning off. Most of the time you'll use the power supply in constant voltage mode. This means the output voltage equals the output setting value and current is determined by the load. Voltage is fixed and current is free to fluctuate based on the load or the resistance of your circuit. If there was a short circuit in your load, current would increase proportionally. That's Ohm's law. That sudden increase in current can damage the components in your circuit. To avoid drawing too much current, you can enable overcurrent protection and set a current limit. To set a current limit, press the menu button under OCP. This is overcurrent protection. You can set a current limit with the left and right arrows. Select the significant digit you want to adjust and use the rotary knob to set a value. You can also key in the value with the number pad. Press the OCP button again to enable overcurrent protection. Take this example. If this was a motor and it began to stall, current would start to increase. Setting a current limit may prevent the motor windings from overheating caused by drawing too much current. This is a good use for overcurrent protection. Another use is if you had a development board, overcurrent protection could save your board if you accidentally make a short circuit somewhere. Just keep in mind the lab power supplies can deliver a lot of power to small electronics. Be mindful of what power you expect your circuit to draw before connecting and energizing the outputs. Pay close attention to what the power supply is outputting. This quarter watt resistor can only handle a quarter watt of power. That's the voltage times the current has to be less or equal to 0.25. This resistor has a resistance of 10 ohms. That means if we push more than 1.5 volts through this resistor, it will exceed its power dissipation limits. Power is dissipated as heat. So for science, let's demonstrate what not to do. This is an example of the power available in this power supply if you're not careful with your circuit setup. Some, but not all, multi-channel power supplies have the ability to connect two identical channels in series or parallel. This could either double the output voltage or double the output current available, but not both. You still cannot exceed the power limits of either channel. Check with the user manual to do this, as the procedures can vary by instrument. This power supplies manual has been uploaded to the Canvas training page. Reference the manual for more details. Be mindful if your test leads can handle high voltage and or current demands. Cheap test leads from generic sellers on Amazon may pose a risk when using high demand power from these lab power supplies. If your test leads ever become warm, stop and reassess your setup. You might need larger gauge test wires. If you see the OTP text, this means the power supply has over temperature protection enabled. If the internals of the power supply exceed its operating limits, the power supply will turn off. If the power supply turns off, it's likely because of this over temperature safety feature. If the power supply feels warm, let it cool down before turning it on again. When you are done using the power supply, remove your test leads. If you borrowed test leads, please return them. Return any borrowed tools and clean up any scraps made during your testing. Turn the instrument off. Remember, you can find more details about advanced features and best practices within the power supply manual, which has been uploaded to the Canvas training page.